And we're back doing a little review of single replacement reactions, and we'll go ahead and talk about how reactivity affects single replacement reactions. So again, a single replacement reaction, very simply, is when a single element replaces part of a compound. In the case of an anion, or if the single element is commonly negative, it'll replace the negative part of the compound and combine with the positive part. Again, if it's a cation, if it's positive, it'll replace the positive part of the compound. So C would replace A in this case. And now we're going to go ahead and keep looking on single replacement reactions, but remember with double replacement reactions, we had to tell if something was soluble or not in order to determine if the reaction would proceed to completion. With single replacement reactions, we do something similar, but now we're looking at reactivity of the elements involved. So you'll find a document that looks something like this that would be helpful to you. And on this side, we basically have two lists. We have activity series of metals, and then we have activity series of halogens, because halogens are realistically the only ones you find by themselves in nature. They're all diatomic, of course. So let's look at this. Rules for the activity series. Rule number 1, any element replace a compound in an aqueous solution of any element below it in the activity series. The larger a gap, the greater the tendency for reaction. So if we look at this, it's going down, it will replace downwards. So lithium will replace rubidium, rubidium will replace potassium, potassium will replace iron. As you go down, if it's above it on the chart, it will replace. Number 2, any metal above magnesium will react to replace hydrogen and water. So here's magnesium, so that means all of these will react with water to replace the hydrogen and water. Number 3, above cobalt replaces hydrogen and steam. So notice there's another line there. So here on up, we'll replace hydrogen in steam. Steam, of course, a little more energy, so a little more reactive. And finally, number 4, any metal above hydrogen will replace hydrogen in an acid and react with oxygen more easily. So there's hydrogen down here. Going up, that will react with acids. So things like copper doesn't react with acids normally. Metals above silver will react easily with airborne oxygen, forming oxides. Not really relevant to what we're talking about now, but it will be beneficial to us later. Any metal below mercury will only form oxides indirectly, so silver and platinum and gold don't form oxides in air. They have to form oxides through other reactions. Oxides below copper will decompose when heated, and oxides below chromium will react when heated with hydrogen. Again, last two not really relevant to what we're talking about right now. Halogens work the same way. As you go down, the more reactive halogens are at the top of the list. So what? What does this mean? Well, let's take a look at a couple of example problems. So here is silver plus potassium nitrate. And if we were progressing normally, silver is a positive 1 charge, potassium is a positive 1, and nitrate's a negative 1, it should form a new substance. Silver nitrate and potassium. But if we take a look at our activity series here, and I find the relevant elements, potassium and silver, there's potassium, and silver is way down here. So we're asking ourselves, is the silver reactive enough to knock the potassium out of the way? And it's not. The silver is less reactive than the potassium, it can't get it out of its way, so this doesn't happen. No reaction occurs. A similar thing can happen with the halogens, right? If I have potassium fluoride plus plus chlorine, potassium fluoride plus chlorine, if I take a look at the halogen activity series, well, fluorine's at the top of the list. Calcium's right below it. But remember, they replace downward, not upward. Calcium or chlorine will not replace fluorine. They don't work. It can't react. So if I have this reaction, nothing happens. No reaction occurs. Now, this isn't true for all cases. There are a lot of things that will react. So say, for example, I don't know, aluminum plus sulfuric acid. All right, so let's take a look at our list. Where is aluminum? Right there. And we're looking for the H because it's an acid, right? Remember, metals above hydrogen will replace hydrogen in acids. Aluminum is above hydrogen, so this means it will happen. This reaction will occur. So the aluminum will replace the hydrogen. Remember, hydrogen, of course, is diatomic, crossing my charges, +3, -2. And then, of course, I could go on and balance this. So that would be a 3, that would be a 2, and that would be a 3. And there I have a balanced reaction, and this one would occur just normally. So, step 1, check out the activity series. Figure out, is this free element reactive enough to replace the one it's supposed to be replacing in the reaction? And then you just proceed as normal. Hope this helps. Again, if you have questions, let me know. Have a great day.